guys, welcome back to my new videos, that is closed loop control of the phase shifted full bridge converter using Matlab Simulink. The circuit diagram shown here is the full bridge converter and the leakage inductance, and the transformer will be there, and after that here the inductance will be the filter and the capacitor will be there. The voltage controller, we are going to use the PI controller here, and after that of saturation block, and we are going to generate the gate pulses using here. H is the feedback transfer function and will be feedback from the VDC. The design specifications are the input voltage will be 210 volts to 373 volt. Output DC voltage will be the 50 volt, 54 volts. The switching frequency is 100 kilohertz. The power rated power of the converter is 540 watts. The maximum duty cycle loss will be the 0.15. The output ripple will be the 2 volts, and output inductance ripple current will be the 0.2 ampere. The crossover will be the less than 10 kilohertz, and fair margin is 25 degree. Now open our Matlab Simulink. DC voltage 210 volts. Required MOSFET. Okay. We'll connect the drain to drain and source to source, and negative terminal to the source and positive to the drain. Required series RLC branch. Right here, and we required L filter of 23.63 microhenry. Okay. Required current measurement to measure the IP. Required linear transformer. Okay. And the parameter will be changed to SI 600, and power rating frequency will be 100 kilohertz. The primary winding voltage will be 18 volt and resistance will be 0.005 and will be 1 e raised to minus 9. Okay. Oh, sorry. 9 e raised to 7, and for secondary winding the inductor voltage will be 6 volt and resistance will be 0.005 and 1 e raised to 7. Same will be for the winding 3. The resistance value will be magnetizing resistance will be e power 6, and inductance value will be 10 milliohm. Okay. We will take from block, name these two PWM 1. Okay. Change to PWM 2. these two M3 change to PWM4. Okay. We required copy this. We will set this with primary current, and we required voltage measurement. Okay. Just measure the voltage across the primary terminal, and we will call this as VAB, voltage across the terminal A and B of the primary side, and required diode. Okay. And we will make these as series. And we required inductance. We required the current measurement, the current through the inductance as well, and we required a capacitor. Change this value to 673, 763 micro ohm, and change this value to C, and it will be 20 micros. And connect to at the center, and connect these two here. Okay. And we will connect, change to resistive load of 5.4 volt ohm. To measure the output current, load current, we have to connect one emitter here. We require voltage measurement to measure the output voltages across the load. Just change to IL, inductor current. Okay. Change this to A0, the output current, and this will be the output voltages. Okay. We will design PI controller for this. So we'll take one subsystem. Okay. And here required constant block, sum block, change to the minus, and this is a PVDC output voltage, and we required one gain block. Change to 1/54, and we required one subsystem for PI generation block. Simulink, and the gain block, the k p will be the 1 and ki will be required integrator limit. Change the value for ki to 100 and change the integrator limit to 0. Upper limit will be 0.5 and lower limit will be 0. Okay, we required a saturation block. And here upper limit will be 0.5 and lower limit will be 0. Okay. Now change to S1. Required constant. And set value as 0.5. Required a repeating sequence. Change this value from 2 to 1 and it will be divided by 100 kilohertz. And required relational operator set greater than, and required logical operator change to not. Yeah. And compare the repeating sequence and we will generate the output, and this will given to S2 and this will for S1. Yeah. Add block change to minus plus and minus. We will give these two here. Okay. And now change to less than, take not get and get. We will compare these two and we will add here take one add block and we will add these two signals. Okay. And we will compare these two here and we record one not get. Okay, we have connected our find these two here for the repeating sequence. Okay. Next Just change here to PWM2 for second, PWM3, and for PWM4 for the switch 4. Now required a scope, yeah, and we will measure the pulses given to the first one, okay, and we will also measure the voltage across voltages and the current, okay. To that we will also, and we will connect one more scope here to measure the output current, the current through the inductor, and the output voltages. Scope, and required power GUI, and we will change this to discrete, and the time will be 1 e raised to minus 7, and here we have to change to trapezoidal. We will click apply and OK. We will change for 1 second, run for 1 second. We can see that both the leg first and leg second has been shifted here. You can see this. Okay. And the current through the primary is changing as well, and for the output voltage and current, you can see that the current through the inductor and the current through the load, this one, and the voltage across the load is almost 52 volts here. If you haven't subscribed my channel, please subscribe it for the new updated videos. Thanks for watching.